15 strange things scientists are watching in the universe. Right now, something is passing through our solar system right now. Astronomers are tracking an object that doesn't belong here. Since the end of 2024, telescopes around the world have been recording an unusual visitor traversing our solar system. It's not a planet, it's not a common asteroid, and it definitely didn't form here. The object entered our neighborhood from outside the solar system, on a trajectory that doesn't follow the natural movement of bodies orbiting the sun. It's traveling too fast for something that was born alongside the planets. This type of visitor is called an interesting object. Until recently, they were just a hypothesis. Today, we know they exist, and now we are observing a new candidate in real time. What makes this object especially intriguing is not only its distant origin, but its behavior. Its speed suggests that it may be older than the solar system itself, a surviving fragment of another star, perhaps from another region of the galaxy. Of course, the internet reacted as it always does. Forums began to speculate, could it be a fragment of ancient technology, an artificial artifact, or even a probe sent by an unknown civilization? Scientists have dismissed these ideas, at least for now. There is no evidence that the object is artificial, but there is also no complete consensus on what exactly it is. Current models show that it may be a body rich in ice and dust, exposed to interesting cold for billions of years. Still, its trajectory and composition did not perfectly fit known patterns. In the coming years, this object is expected to pass relatively close to gas giants like Jupiter. If this happens, the planet's gravity may slightly alter its path, offering astronomers a rare opportunity to study how interested visitors interact with planetary systems. Why is this important? Because each object like this is a physical message from the galaxy's distant past. It carries information about how other star systems formed, how matter is distributed in space, and how common or rare the type of environment that gave rise to life here might be. We are used to thinking of the solar system as something isolated, but this visitor is a stark reminder that it's part of a much larger network, where fragments of dead stars cross paths by sheer chance. And this won't be the last. With new telescopes coming online, scientists expect to uncover discoveries from these objects in the coming years. What once seemed like science fiction is rapidly becoming astronomical routine, and if something like this can silently pass through our cosmic neighborhood, that raises a much bigger question. Because this isn't the only thing in space that appears far more organized than it should be. A structure in the Milky Way is almost too perfect deep inside our own galaxy. Astronomers have found something that looks unnaturally precise. Using advanced radio telescope systems, scientists have identified a massive structure hidden within the Milky Way. It's not a star, it's not a planet, and it doesn't emit visible light. What caught their attention was its shape. It's almost perfectly spherical. In space, this is extremely rare. Most things form chaotically. Explosions, collisions, and gravitational fields create irregular, distorted, and asymmetrical shapes. Geometric perfection is simply not the norm in the cosmos. And yet, this structure stands out as if it were intentionally designed. It was detected via radio waves, meaning we're not seeing a solid object, but an expansive shell of energy and gas, invisible to the naked eye. For astronomers, the most likely explanation is that it's the result of an extremely powerful stellar explosion that occurred in the distant past. The problem is that this type of explosion, the supernova, rarely produces something so uniform. Normally, stars die violently and chaotically. Material is ejected in all directions, forming irregular clouds. But in this case, the expansion appears to have occurred in a surprisingly balanced way, creating a sphere so well defined that it has left researchers genuinely baffled. Another detail makes it even stranger. We don't know exactly where it is. Distance estimates vary enormously, meaning this structure could be relatively close, or located in a much deeper region of the galaxy. This uncertainty makes it difficult to calculate its true size. Depending on the correct distance, it could range from large to absolutely colossal. This has led some researchers to question whether we are seeing only the remnants of a single explosion, or the result of a more complex process, perhaps involving multiple perfectly synchronized events. Naturally, more speculative theories quickly emerged. The best hypothesis is that we are observing a rare combination of conditions, a specific stellar explosion occurring in an unusually uniform environment without significant gravitational interference around it. But until more data is collected, this sphere remains one of the most visually perplexing structures ever detected within our own galaxy. And it raises an uncomfortable thought, because symmetry on this scale doesn't just look strange. It forces scientists to ask whether the universe itself is more ordered than we assume. Something is sending extreme energy straight toward us right now. Earth is being hit by bursts of energy powerful enough to punch through our atmosphere. Most of the time, space feels distant, quiet, harmless. But that's an illusion. Every so often, detectors on Earth register something extraordinary, particles arriving with so much energy that they shouldn't even be able to reach us in one piece. They're called ultra-high energy cosmic rays. and some of them hit harder than anything we can produce on this planet. When they slam into the atmosphere, they explode into cascades of smaller particles, spreading across miles of sky. We can see the aftermath. We can measure the energy. But the real mystery is where they came from, because whatever launched them had to be violent beyond imagination. First, scientists blamed exploding stars. Supernova are powerful enough to fling matter at insane speeds. But the strongest of these particles don't quite fit that explanation. They carry more energy than a single dying star should be able to provide. So attention shifted to darker places. Black holes, colliding neutron stars, the cores of active galaxies tearing themselves apart. All of those are capable of extreme acceleration, but there's a problem. By the time these particles reach Earth, their paths are completely scrambled. Magnetic fields twist their trajectories, erasing the trail behind them. It's like trying to figure out where a bullet came from after it has bounced off 1,000 mirrors. We know they're coming from outside our galaxy. We know they're incredibly rare. And we know that something, somewhere, is firing them off. But we don't know what, or why. That uncertainty matters. Because these particles aren't just curiosities, they're messengers. Each one carries information about environments so extreme that they push physics to its limits. And the fact that we're redetecting them at all means the universe is still actively producing events powerful enough to reach across billions of light years and touch our planet, even now. And if energy like this can reach us without warning, then it means the most extreme objects in the universe may be closer and more common than we once believed. Black holes are showing up closer than we expected for a long time. Black holes felt like distant monsters, powerful, but safely far away. That idea is starting to fall apart. Astronomers have known for years that a supermassive black hole sits at the center of the Milky Way. It's massive, quiet, and thankfully far from us. But recent observations suggest that another massive black hole may be lurking much closer than anyone expected in one of our neighboring galaxies. The Large Magellanic Cloud is a small galaxy orbiting the Milky Way. It's close enough that we can see it with the naked eye on a clear night. For decades, it seemed calm, ordinary, predictable, until scientists noticed something strange. Stars near the edge of our own galaxy were moving too fast, much faster than gravity alone should allow. Some were being flung outward at speeds high enough to escape the Milky Way entirely. That kind of motion doesn't happen by accident. When researchers traced those stars backward, their paths didn't point toward the center of our galaxy. They pointed somewhere else, straight toward the Large Magellanic Cloud. The best explanation is unsettling. A massive black hole, hundreds of thousands of times more massive than the Sun, may be hiding there, invisible, silent, but powerful enough to grab stars, slingshot them across space, and send them racing toward us. We don't see the black hole itself. That's normal. Black holes don't glow. They don't shine. They reveal themselves only through what they disturb. And in this case, they're disturbing stars on a galactic scale. What makes this discovery so important is distance. This would be the closest massive black hole outside the Milky Way ever identified, close enough to influence our galactic neighborhood, close enough to remind us that black holes aren't rare anomalies, they're common features of the universe. Most galaxies have one, some have more, and they don't just sit quietly forever. They grow, they merge, they reshape entire galaxies over time. Black holes aren't just cosmic vacuum cleaners, they're architects. They control how galaxies evolve, how stars move, and how matter organizes itself on the largest scales imaginable. The more we look, the clearer it becomes. The universe isn't just expanding, it's being sculpted, and that leads to an even bigger question. If objects this extreme are shaping galaxies, what happens when we start looking for life in places that don't look anything like Earth? The universe may be spinning as a whole. When scientists looked deep into the early universe, they noticed something that shouldn't really exist: patterns. When astronomers map some of the oldest galaxies ever observed, they expect randomness. After all, the universe was born in chaos, matter exploding outward, colliding, clumping, drifting. But that's not exactly what they're seeing. Instead, a surprising number of early galaxies appear to rotate in the same direction. Not half one way and half the other, but a clear majority spinning clockwise. And it's not a small imbalance. Roughly 2/3 of these ancient galaxies rotate the same way. At first, researchers assumed it had to be an error, instrument bias, sampling issues, something wrong with the data. But as the data sets grew and methods improved, the pattern refused to disappear. That opened the door to a question no one expected to ask. What if the universe itself has a preferred direction? We already know that rotation is everywhere. Planets spin, stars spin, galaxies spin. Rotation isn't rare, it's fundamental. So extending that behavior to the universe as a whole sounds radical, but not impossible. If the universe began with even a tiny amount of angular momentum, that motion could have been amplified as space expanded. If that's true, then the universe isn't just expanding outward, it's turning. This idea doesn't overthrow cosmology, not yet, but it does challenge the assumption that the universe has no large-scale orientation. And that matters, because many of our models quietly assume perfect symmetry. If the universe has a built-in spin, it could help explain why motion, structure, and organization appear everywhere we look, even at the largest scales. For now, scientists are cautious. The evidence is intriguing, not definitive, but it's strong enough to keep showing up in serious research. And once you notice it, it's hard to ignore. Because rotation isn't just something objects do, it may be something the universe has been doing since the very beginning. We may be living inside a massive cosmic void on the largest scales imaginable. The universe may not be as evenly distributed as we once thought. For decades, astronomers assumed that matter in the universe spreads out fairly smoothly when viewed on truly massive scales. Galaxies cluster. Yes, but overall, the universe should look balanced in every direction. That assumption is now under pressure. When scientists study ancient sound waves left behind by the Big Bang, subtle patterns frozen into the structure of space itself. They see hints that our region of the universe might be unusually empty. Not empty like space feels empty. Empty on a cosmic scale. This idea connects directly to one of the biggest problems in modern cosmology, something known as the Hubble tension. When astronomers measure how fast the universe is expanding using nearby galaxies, they get one answer. When they measure the same expansion using the early universe, they get a slower one. Both methods are solid. Both have been checked repeatedly, and yet, they don't agree. One possible explanation is unsettling. What if the Milky Way sits inside a gigantic void, a region with fewer galaxies and less matter than average? If that's the case, denser regions outside the void would pull more strongly, making nearby space appear to expand faster from our point of view. In other words, the universe might not actually be accelerating differently in different eras. We might just be standing in a strange place. If this cosmic void is real, it would stretch across hundreds of millions of light-years, large enough to affect how we interpret the expansion of the entire universe, large enough to quietly distort our measurements without us realizing it. This doesn't mean the Big Bang was wrong. It doesn't mean cosmology is broken. But it does mean that location matters, even on scales we once believed were uniform, and that realization changes how we read the universe. Because if where we are affects what we measure, then some of our most trusted conclusions may depend on perspective more than we ever expected. And that raises a deeper concern. If large-scale structure can quietly shape our observations, then we may be misunderstanding what the universe is actually made of. Most of the universe is made of something we cannot see. When scientists first added everything up, the numbers simply did not make sense. Stars, planets, gas, dust, entire galaxies, even after accounting for all of it, something was missing. In fact, most of it was missing. According to our best measurements, everything we can see, every star in every galaxy, makes up less than 5% of the universe. The rest is invisible. It does not emit light, it does not reflect light, and it does not behave like normal matter. This unseen substance is what scientists call dark matter. We know it exists because of what it does. Galaxies rotate too fast to hold together using visible matter alone. Galaxy clusters bend and warp the light passing behind them, distorting space in ways that can only be explained by additional mass. Mass we cannot see. Dark matter functions like a cosmic scaffold. It shapes galaxies, holds them together, and determines how large-scale structures form. Without it, the universe would look nothing like it does today. And yet, we still do not know what it actually is. It does not interact with light. It barely interacts with normal matter. It passes through everything, including us, without leaving a trace. Right now, trillions of dark matter particles may be passing through your body every second, not because they are dangerous, but because they almost never interact with anything at all. Scientists have built detectors deep underground to shield them from interference, while others look to space, hoping to detect signs of dark matter collisions or decay. So far, it has remained stubbornly silent. Recently, however, researchers have found indirect ways to study it. By using fast radio bursts, brief, powerful flashes from distant galaxies, astronomers can measure how invisible matter slows and distorts these signals as they travel across the universe. It is like shining a flashlight through fog you cannot see and measuring how the beam changes. This has helped confirm something remarkable. The missing matter is not missing at all. It is spread thinly between galaxies, filling the vast regions we once believed were nearly empty. It is subtle and difficult to detect, but it dominates the universe's mass. This leads to a humbling realization. Everything familiar, planets, stars, even life itself, exists within a framework built almost entirely from something invisible. And that forces an uncomfortable thought. If most of the universe is made of something we cannot see, what else might be happening right in front of us without us ever realizing it? Some stars are exploding more than once. For most of astronomy, a star exploding meant one thing: the end. A supernova was understood as a single, violent finale, a massive release of energy followed by silence. But that picture is no longer complete. In recent years, astronomers have captured clear evidence of something far stranger: stars that explode, survive briefly, and then explode again. These events are known as double detonations supernova, and they challenge one of the most basic assumptions about how stars die. In many of these cases, the star is already in the final stage of its life, a white dwarf, the dense core left behind after a sun-like star burns through its fuel. On its own, a white dwarf is stable, quiet, and harmless. The trouble begins when it has a close companion. If another star orbits nearby, the white dwarf can begin stealing material from it, slowly and invisibly. Gas accumulates on its surface, compressing under immense gravity. Eventually, the outer layer ignites first. That initial surface explosion sends a shockwave racing around the star. And when the wave converges on the core, it triggers a second, far more powerful detonation. 2 explosions, 1 star, separated by mere seconds. This matters because these explosions are not just dramatic, they are essential. Double detonation supernova are one of the primary sources of heavy elements in the universe. Iron, nickel, and the materials that later become planets, mountains, machines, and even blood. Every atom of iron in your body was forged in a stellar explosion like this. What makes these events especially unsettling is how recently we confirmed them. For decades, they existed only in theoretical models. Now we are observing them directly in distant galaxies, unfolding exactly as predicted, which means the universe is still actively recycling itself, destroying stars in precise and deliberate ways to build complexity elsewhere, even now. And once you realize stars do not always die the way we expected, it becomes clear that entire worlds may be breaking apart right in front of us. We are watching a planet die in real time. Right now, astronomers are observing a world that is slowly tearing itself apart. The planet orbits its star so closely that an entire year lasts barely more than a single day. It is trapped in a gravitational death spiral, pulled inward while being cooked by relentless heat. Surface temperatures rise high enough to melt rock, not soften it, not crack it, but turn it fully into liquid. With every orbit, the planet loses part of itself. Its outer crust boils, peels away, and streams behind it, forming a glowing tail of vaporized rock that stretches millions of miles through space. From a distance, it looks less like a planet and more like a comet made of stone. This destruction is not theoretical. It is happening now. Astronomers detected it by watching the star's light dim in an unusual way, not clean and symmetrical like a normal planetary transit, but smeared and uneven. Something was blocking the light and then drifting away. That something was the planet itself. Each orbit strips away enormous amounts of material, and over time the loss compounds. Scientists estimate this world is only a few million years left before nothing remains but dust and gas spread along its former path. On cosmic timescales, that is the blink of an eye. What makes this discovery so important is not the spectacle, but the insight. We almost never get to watch planets change in real time. Most planetary evolution unfolds over billions of years. Here, the process is fast enough to observe directly how atmospheres escape, how surfaces break down, and how gravity and radiation can reshape entire worlds. This dying planet offers a glimpse into the future of many others. As stars age and expand, more planets will be pulled inward, heated, stripped, and erased. It is a reminder that planetary systems are not permanent, they are temporary arrangements, balanced over vast stretches of time, but never infinite. And if planets can vanish this quickly, then even the worlds we think we understand may be hiding surprises beneath the surface. Some planets are giving off more heat than they should. Some worlds are warmer on the inside than physics says they ought to be. When planets form, the process is violent, collisions, compression, and enormous heat trapped deep within their interiors. Over billions of years, that heat is supposed to slowly leak away into space. That is the theory. But when scientists took a closer look at certain planets in our own solar system, the numbers did not add up. One planet in particular stood out: Uranus. For decades, Uranus was considered an anomaly. Unlike Jupiter and Saturn, which radiate far more heat than they receive from the Sun, Uranus appeared almost cold internally. Data from Voyager 2 suggested it had lost nearly all of its internal heat, which made no sense. A planet that massive should not cool down so quickly. More recent measurements finally clarified the picture. Uranus does release heat, just not very much, about 12% more than it receives from sunlight. That excess energy is real, and it is coming from deep inside the planet. The mystery is why Uranus behaves so differently. The leading explanation points to its extreme tilt. Uranus rotates almost entirely on its side, as if it were knocked over early in its history. That tilt likely resulted from a massive collision. If such an impact rearranged the planet's interior layers, it could have disrupted how heat travels from the core to the surface. Instead of escaping evenly, the energy may be trapped, leaking out slowly and irregularly, and Uranus is not alone. Other planets and moons show signs of internal heat that cannot be fully explained by sunlight or simple cooling models. Some are heated by tidal forces, others may conceal chemical reactions or structural processes we do not yet understand. What this reveals is critical. Planets are not passive objects. They are dynamic systems with interiors that evolve, shift, and sometimes behave in ways our models fail to predict. Even worlds that appear quiet and inert on the outside can be active beneath the surface. That hidden energy matters. It influences atmospheres, shapes geology, and in some cases determines whether a world remains dead or becomes active, which means planets may be doing far more than simply orbiting their stars. Some of them may be hiding vast structures beneath their surfaces. The Moon and Mars may be hiding massive structures beneath their surfaces. Some of the most important discoveries are not happening on the surface at all. For a long time, both worlds were considered dead cold, silent, and geologically finished. That picture is now changing. On the moon, high-resolution images have revealed deep pits with sheer walls dropping straight into darkness. These are not impact craters. They are skylights, openings into enormous lava tubes formed billions of years ago when molten rock flowed beneath the surface and later drained away. Some of these tunnels may stretch for hundreds of miles, and they are vast, large enough to hold entire cities. They could shelter future human explorers from radiation, micrometeorite impacts, and extreme temperature swings because conditions underground are far more stable than on the surface. This means the most realistic future moon bases may not sit on the moon, but exist inside it. Mars tells a similar story. Data from NASA's InSight lander revealed something unexpected beneath the Martian crust. Seismic waves traveling through the planet slow dramatically several miles below the surface, a change that solid rock alone cannot explain. Liquid can the leading explanation is a massive underground layer, possibly water, trapped deep beneath Mars's surface, not frozen, not vapor, but liquid held under pressure. If this reservoir exists, it radically changes how we understand Mars. Water enables chemistry, chemistry enables energy, and energy opens the door to activity. This does not mean life exists there today, but it does mean Mars may not be as dry, dead, or simple as it appears from above. Together, these discoveries tell a quiet but powerful story. Planetary surfaces can be deceptive. Worlds that look lifeless may still be active below, shaped by heat, pressure, and hidden structures left behind by violent pasts. As scientists plan future robotic and human missions, they are increasingly looking downward rather than outward, because the safest environments, the most stable conditions, and the biggest surprises may all be underground. And once you start looking below the surface, it becomes clear that even entire planetary systems may be forming in ways we never expected. Planets may be forming without stars. For a long time, we assumed planets needed stars in order to exist. Stars formed first, planets came later, and that sequence felt unquestionable. But recent observations are quietly breaking that assumption. Astronomers studying rogue planets' worlds drifting through space without orbiting any star winds believed they were nothing more than cosmic leftovers. Ejected from their original systems and condemned to wander in darkness, lonely, cold, and inactive. That picture no longer holds. When researchers observed several massive rogue planets using infrared telescopes, they detected something unexpected surrounding them. Disks of dust and gas, not random debris, not scattered remnants. Organized disks, the same kind of material normally seen around young stars where planets are actively forming. This raises a startling possibility. Some rogue planets may be forming their own moons. Others may even be giving rise to entire miniature systems, all without a central star. In other words, planet formation may not depend on sunlight at all. If gravity and raw material are present, nature appears to find a way to organize them. This dramatically reshapes how common planets may be in the universe. Rogue planets are believed to be extraordinarily numerous, possibly even more common than stars themselves. If even a small fraction of them can host moons or secondary worlds, then the total number of planetary bodies in the galaxy could be far higher than we ever imagined. It also challenges a deeper assumption that warmth, light, and potential habitability must always come from a star. These drifting worlds may generate internal heat through pressure, radioactive decay, or tidal forces within their own systems. Some may even hide subsurface oceans, warmed from the inside rather than the outside. It is a reminder that formation does not follow a single blueprint. The universe experiments. It builds worlds in places we never thought to look quietly, patiently, and often in complete darkness. And once you realize planets may not even need stars, it forces us to rethink how young worlds begin their lives. We detected energy that shouldn't have reached us. In 2022, the universe sent a signal so powerful it shattered expectations. For a brief moment, space itself seemed to light up as astronomers recorded the most intense explosion ever, observed a gamma ray burst so bright it earned the nickname BOAT, the brightest of all time. It originated in a galaxy nearly 2.5 billion light-years away, which alone was extraordinary. But what followed was far more unsettling. Some of the particles that reached Earth carried far more energy than our models say should survive a journey of that length. In theory, that energy should have been absorbed, scattered, or degraded long before arriving here, but it wasn't. We detected it clearly. Gamma-ray bursts occur when massive stars collapse into black holes, releasing narrow jets of energy, moving at nearly the speed of light, violent, brief, and incredibly rare events. This one was different. The energy it delivered pushed the limits of known physics and forced scientists to confront a difficult question. How did that energy make it here intact? One possible explanation points to something deeply unfamiliar: particles that barely interact with normal matter at all. Some researchers suggest the gamma rays may have temporarily transformed into axion-like particles as they traveled through space, slipping through the universe with far less resistance before converting back into gamma rays closer to Earth. If true, this explosion did more than light up the sky. It may have offered indirect evidence of new physics, possibly even linked to dark matter. Scientists remain cautious. This is not a confirmed discovery, but the fact that we observed energy behaving this way at all reveals that our understanding of how the universe transmits extreme power is incomplete. And that is the point. The universe is still capable of surprising us, not with subtle hints, but with signals so overwhelming they force us to rethink the rules of it across billions of years. And when energy like that can cross the universe, it suggests the cosmos may be far more connected and far more organized than we ever assumed. The universe is organizing itself. The universe was born in chaos, but it no longer looks chaotic. When scientists map the large-scale structure of the cosmos, they do not see randomness. They see patterns. Galaxies are not scattered evenly through space. They align along immense filaments that stretch across hundreds of millions of light-years. These filaments intersect at dense hubs, forming vast cosmic webs, separated by enormous, empty regions. From a distance, the structure almost looks intentional, yet it was not present at the beginning. Early space was simple, composed mostly of hydrogen, a little helium, and little else. Over time, gravity pulled matter together. Tiny irregularities grew, certain regions became denser than others, and patterns emerged. Then those patterns kept building. What makes this striking is how familiar the process feels. In biology, simple rules give rise to complex systems. Cells organize into tissues, tissues form organs, and complexity increases layer by layer, guided not by a master plan but by constraints and feedback. The universe appears to be doing something similar. Galaxies cluster like networks. Matter flows along invisible pathways. Structure arises naturally from simple forces acting repeatedly over immense spans of time. Some researchers have even noted visual similarities between cosmic filaments and neural networks, not because the universe is a brain, but because organization follows rules regardless of scale, and this organization continues to intensify. Each generation of stars produces heavier elements. Those elements form planets. Planets create environments where chemistry grows more complex. Violence gives rise to structure. Destruction opens the door to possibility. This does not mean the universe is conscious, and it does not mean it has intentions, but it does suggest that complexity is not accidental. Given enough time, simple laws can generate extraordinary order, which leads to a quiet but profound idea. Maybe the universe is not only expanding, maybe it is developing. And if that is true, then everything we have seen may be part of a much larger process. We may be witnessing the universe in motion, not just an expansion. When you put all of this together, something unsettling begins to emerge. We tend to think of the universe as a finished thing, already built, already decided. But what we are actually seeing tells a very different story. Objects passing through our solar system from elsewhere, precise structures hidden inside our galaxy, energy reaching us that should not have survived the journey, black holes shaping entire regions of space, planets being destroyed while others form in complete darkness, worlds releasing heat from deep within, hidden oceans, invisible matter holding everything together, explosions powerful enough to force physics to rewrite itself. Vast structures organizing over billions of years. None of this feels static, it feels active. It feels like a process still unfolding. The universe is not just getting bigger, it is becoming more complex. Every generation of stars leaves behind heavier elements. Those elements build planets. Planets enable chemistry. Chemistry creates environments where entirely new behaviors can emerge. This is not chaos slowly fading away. It is structure building on top of structure, and that leads to an uncomfortable realization. We are not observing the aftermath of creation, we are watching creation continue. Right now, not locked in the distant past, not frozen inside equations, but unfolding violently, patiently, and relentlessly across scales. We are only beginning to understand. The universe does not pause, it does not settle, it does not stop surprising us. And the more closely we observe, the clearer it becomes. We are not outside this process. We are part of it. And the next discoveries may not just change how we see the universe, they may change how we understand our place within it. If you made it this far, you have already seen something important. Not answers, but patterns. And the universe is full of them. If you want to keep exploring what we still do not fully understand, there is more waiting, more signals, more contradictions, more discoveries unfolding right now. Stay curious and stay with us.